Page 36. Divide by one-digit divisors. Okay. One-digit divisors mean the number in which you are dividing by is only one digit. So anywhere from 1 to 9 are what we're going to be working with for today. I always have a struggle with this as basically the first lesson that sixth graders have with division. Usually division isn't one of our major strengths coming in. Doesn't mean that it won't be this year. I'm hoping that it's going to be fine. But I think the whole process and the whole understanding of it takes some getting used to. See, most of you, when you've done your division problems up to this point, if things didn't work out evenly, you ended up using what was called the remainder. Raise your hand if you're familiar with the remainder. Okay, well, we're going to make the transition this year, who knows, maybe today, to completely doing away with the remainder. To me, the remainder is so elementary. And I don't really know exactly what it teaches you. But I'm also not in the classroom when you start with your division. I don't know what grade that is. But so let's go through some review with some basic division. 396 divided by 6. Now, if you remember anything about your division, that where you put your digits up top, it's going to be extremely important. Things have to be lined up well. If you are just putting numbers up here with no rhyme or reason, you're going to have some trouble. So just like how you would read a book, how you go left to right, you do the same thing when you divide. So does 6 go into 3? Say no. And I'm going to ask myself that question every single time. Always check that number. Do I need to put a 0 there if it's my first digit? No, I think I can figure that out. Now say, into 39 would be 6. So where should I put the 6? Above the 9. Very good. Subtract 3. Bring my 6 down. 6 into 36 again. 6 goes over the other 6. And lo and behold, it works out evenly. Okay? No remainder. Any questions on the process? Yeah, Casimir. Okay, well, don't think of something different. Think about what's up on the board. Okay? Yes? Over the 3? You don't need anything over the 3 if 6 does not go into 3. We could skip right over it. Go 30, 39, whatever that is. Okay? 641 divided by a 7. Okay? When you do the division on your paper, make sure you give yourselves plenty of room. Cramming things together just causes more confusion. All right, so Larissa, does 7 go into 6? So I can skip over that 6. How about 7 into 64? How many? 8 would give me 56. Let's try 9, and that would be 63. 64 minus 63 is what, Larissa? 1. And then I drop the other 1 to make it 11. How many times does 7 go into 11? Once. So under the old system, what would my final answer be? Desriana. 91, remainder 4. Any questions on that? Yeah, Larissa. Please excuse my dear Aunt Sally. I don't either. Desriana, what is she talking about? D. This? Okay. Good. DMSB. Try that one. It's 2 going to 1. Desriana. How about 14? How many? So 7 over the 4 and 14, right? And that would be 14. Drop the 2. How many times is 2 going to 2? Once. 0. Drop the 3. Would be another 1. 1 left. Okay, 711. And 1. Now the problem I have with this is it's never really done. These are never really done. Why aren't they ever really done? Yeah. They have a remainder. Like, what is that? The only time you should be seeing letters at this point is if they're variables. A remainder. So let's take a look at the same problem. We'll look at the same problem, and I'm going to show you something else where we can finish it. So rewrite this down, get this down in your notes. Big boy math, 101. Now, when I start to work through, and I start working through just like we did, then I get to this point with the 3, and I get 1 left, right? Okay, same problem that we just had up on the board. I want to show you something that we can do. We can actually finish it. And some problems will work out, some won't, but that's okay. At least we'll have a better idea. Now, I am not quite yet finished. 1,423, where's my decimal in that number? Because every number has one. We didn't need to write it down up until this point because there wasn't anything after it. Does not? Right here. Okay? So what I'm going to do is I'm going to shoot that decimal right up there. What can we add, and as many of them as we want, to the back end of that number? Kayla, 0. So here, let's do this. We'll just add zeros as needed, and then we'll bring them down. How many times is 2 then going to 10? Larissa? 5, and it's finished. Now, 711.5, that have a little bit more meaning to you as opposed to 711 remainder 1? So remainder 1, depending on what you're dividing by, is going to be different. It's not always going to have the same value. It's not, was it 0.1 because it was remainder 1? No. So once we start looking at these problems and looking at the division and saying, you know what, we're not just done because we've gotten to the end of our number. We can add many different zeros after it. Let's take a look at another one and then just kind of see where it goes. But the concept itself would work out to be okay. 367 divided by 8. Now let's kind of work through this together as we're still getting used to this. A good habit to get into once you've graduated into the big boy math, anytime you have division, go ahead and just, if there isn't already a decimal in there, put one in. And it goes straight up. So kind of like with multiplication, you take care of the decimal last, right? With division, you take care of the decimal first. It's the opposite. Well, isn't multiplication the opposite of division anyway? So you do the opposite. All right, so bear with me. Process stays the same. Every place up top has its perfect spot. 8 into 3, no. 8 into 36, Desriana. 4, so I'm going to put that 4 right over the top. And I'm going to get 4. Drop to 7. How many times is 8 going to 47? Eli? 5 is 40. Good. Okay, now ordinarily I'd have remainder 7. But, Frank, and a 0, let's drop that guy down. Now it's 70. 8 into 70, how many times? Whoa, that's a lot of times. 8 times is 64. Oops. Got a 6 left. What do I do now? That's Rihanna. No. Frank, got another 0. 8 into 60. 7. Which is? And I got a 4 left. What to do, what to do, what to do. Alexis, another 0. 8 into 40. 8 into 40. 5 gives me 40. Done. So in our first example, we only went to the 10th place. Now we went all the way to the 1000th place, and that's okay. We took it to completion. It's done. It's over. There's not this remainder hanging out there in space where we don't really know what the value is. Yes? Don't say the C word. Alexis. There's no remainder left over anymore. It's just part of our, yes. Just put a decimal and just keep it rolling. Keep it rolling. Now, there are other cases in which, let's say, This is now entirely possible. In the past, you would have said, no way. 9 does not go into 4. You can't put the bigger number on the outside and the smaller one on the inside. What's the matter with you? Your possibilities now are limitless. Big boy math, first thing I'm going to do is what? The decimal up here, okay? Does 9 go into 4? 0. Does that mean I'm done? Oh, sorry, not that easy. 0. 9 into 40. Ooh, 4 left. What do I do? Frank. 9 into 40. Pete and Repeat went out on a boat. Pete fell in. Who was left? Pete and Repeat went out on a boat. Pete fell in. Who was left? Pete and Repeat went out on a boat. Pete fell in. Who was left? You keep saying repeat, right? This is known as a repeating decimal. Yes, it would go on and on and on and on forever. What is actually repeating in this problem? Casimir. The 4. Good. You don't have to, if it's repeating, you have to say it 4 times. Your final answer would be 0.4. Then I put a bar over the top of it to let you know that that's the part that's repeating. Bar notation. Casimir. Let me ask you a question. Casimir. What's that number? What's that number? 4. 4.0 or just what? 4. What's that one? 4. Did we not just use a 4? Isn't this just a 4 with all the zeros? It's still a 4. But now we're able to find out for sure what's its value. You know, how many times could you squeeze a 9 into a 4? Well, 4 is almost half, right? 0.4 is almost half. 0.44 is almost half. What's half as a decimal? 0.5. So it's almost half. Not quite. So I don't expect you all to understand this in the 5 minutes that we spent looking at it. But it's just something to kind of get your brain working a little bit that this is where it's headed. Now, we're not going to, this isn't going to be part of your assignment today. I'm going to let you, you know, you need your blankies, you need your teddy bears, you need to curl up with your big letter R's because that's what you're comfortable with. You did some big boy math today. Yes, ma'am. All right. We'll do one more. Give it a shot. Worksheet 2-3, 1 through 12, pick 8. Any 8 that you want. Can you do all of them for extra practice, not extra credit? Now, if you want to use remainders, that's okay. Or try big boy. Up to you. Yes, ma'am. You may. Yes. Okay? It's up to you.